Let's do a few examples on scientific notation. So we have to fill in the table. It has the same numbers written in different ways. So let's say in scientific notation form we have 6 times 10 to the 5th power. So in the in-between calculation would be 6 times we have 10 to the 5th power, so that's like saying we have 5 zeros with the 1. So 1 plus the 5 zeros, 1, 2, 3, 4, 5. So we have 5 zeros. So it would be 6 times 100,000. And the normal way, so we basically multiply 6 times 100,000, and it gives us 600,000 as our final answer. Okay, so let's do another one. 2.5 times 10 to the 5th power, and we want to do the in-between calculation. So we do 2.5 times, we have 5 zeros with the 1, so it'll be 1 plus the 5 zeros, 1, 2, 3, 4, 5. So we have 2.5 times 100,000, which would give us 250,000 when we multiply. That would be the normal way. Okay, let's go to our let's do another one. Scientific notation. 5.39 times 10 to the 4th power. So we have 5.39 times. So we have 10 to the 4th power. So that would be 4 zeros plus the 1. So we have 1 and 4 zeros. So it would be 5.39 times 10,000, which would give us when we multiply 53,900. Okay, we have now 2.03 times 10 to the 6th power. So in the in-between calculation we would put 2.03 times, so we have 6 zeros plus the 1, so 1 and 6 zeros. So it would be 2.03 times 1 million, and when we multiply that out we get 2,030,000. 2,030,000 would be the normal way. Now let's say we have 8.904 times 10 to the 3rd power. Now, so we write it out like this in the in-between calculation. We have 8.904 times, we have 3 zeros plus the 1, so we 1 and 3 zeros. So it'd be 8.904 times 1,000, which would give us 8,904 as when we multiply it. So that would be the normal way. Okay, let's do another one. We have 1.5594 times 10 to the 8th power. So we write it out in the in-between calculation, 1.5594 and times, we have 8 zeros plus the 1, so we have 1 and 8 zeros, 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 zeros, so we separate them with commas, and so our in-between calculation would be 1.5594 times 100 million. So when we multiply this out, we would get 155,940,000 as our final answer. So this would be the normal way of writing this. Okay, we have directions that are telling us write the numbers in scientific notation. So we have 13,000. So we have 13,000. So we have 3 zeros, and we want to put a decimal point between the 1 and the 3. So it'd be 1.3 times 10 to the 4th power, because the 3 counts as a place 2. So it would be 1.3 times 10 to the 4th power. So we have 4 spaces to the right of the decimal point. So it'll be 1.3 times 10 to the 4th power. So this is the final answer, and this is in scientific notation. Okay, right here we have 204,000, and we want to write in scientific notation. So we have 1, 2, 3, 4, 5. We have 5 places. And we put a decimal point right here between the 0 and the 2. So it would be 2.04 times 10 to the 5th power. As you can see, we have 5 places, 1, 2, 3, 4, 5. So 10 to the 5th power. So it would be 2.04 times 10 to the 5th power as our final answer. Okay, the next directions are telling us write the numbers in scientific notation in the correct way. So we have 26 times 10 to the 6th power. So we basically would add 6 zeros. So it would be 26 plus the 6 zeros. 1, 2, 3, 4, 5, 6. So we end up with 26 million. And then we're going to write it in scientific notation in the correct way. So we put a decimal point between the 2 and the 6. So we have 2.6 times, and how many places do we have? So we have 1, 2, 3, 4, 5, 6, 7. So it would be 2.6 times 10 to the 7th power. So this would be the correct way of writing this in scientific notation. So let's now move on to a few exercise problems so we understand the concept of what are we doing here.